many of you have checked your Google Classroom for the YouTube videos? How many of you? Have you checked your Google Classroom? Are the videos clear over there? Okay, guys. So this is all about the spur gear design problems. Okay. Now, so if you observe from last all problems, we had common procedure. What was that common procedure? First thing, what we used to do is we used to check which one is a weaker part. Okay. Based on that particular weaker part, we used to carry out our other design procedures. Number two, we used to find the module. Number three, we used to find the dynamic load. Next, to check the dynamic load, we used to find the endurance load or endurance strength, I can say. Endurance strength. Okay. Once again, I have missed something here. So once we have calculated module, we used to check for design stress. Okay, we used to check for design stress. If everything is okay, it's fine. If it is, if the design stress value is very less than the comparable allowable stress value, it has to be less. If it is more than the allowable stress value, what is to do? We used to increase the module. Next, we used to calculate the dynamic load, and we have to compare with the endurance state. And I have told you that apart from all the loads, this has to be the smaller one. Okay, this has to be the smaller one. And even if in the question, if he has asked, we used to even calculate the wear load. We used to even calculate the wear load and check again with the dynamic load. So if it is if it is more than the dynamic load, then it is okay. Dynamic load should be a minimum one, no? So if it is more than the dynamic load, then it is fine. If it is not, we used to increase our VHN as described in the last problem. So this is the common procedure for every problem on the spur gears. Okay. Understood? So we will be solving a last problem on the spur gears where it has all this stuff. So it has identifying the weaker part, calculating module, dynamic endurance, and wear. So all the stuff are there in that particular problem. After this, we will be moving to the helical gears. So I want everyone to solve this particular problem now. Okay. Okay, this is the problem number 5, I guess. So if you take this particular problem and just write the given data, the power to be transmitted, just write the given data. The power to be transmitted is 20 kilowatts. Okay. And the speed of the gear and the pinion, we will just write. So it is 20-degree full depth involute system. Okay. So I'll be having a gear and a pinion now. Okay. So N1 is 12,000 RPM. Just shift this apart. And even for the Z1, I have 16 teeth. So this is the pinion and this is the cap. Pinion, I will be taking it as 1, and the cap, I will be taking it as 2. Now, I is given in the problem. I is 3:1 speed ratio. This is very, very important, and a new thing. Assume that starting torque is 20% more than the mean torque. So I can say MT max is 20% more than the normal MT. That is the statement given in the problem. Okay. Now, immediately you calculate the values of N2 and NZ2 with the help of I. So you know that I value was nothing but N1 by N2, or it is Z2 by Z1. From this you can calculate the values of N2 and Z2 as 448 teeth. So 400 RPM. And this one is 48 teeth. Okay. And aptitude specialists in this particular class would be helpful, should have to help me with this. If it is 20% more than MT, have to write in decimals. How should I write it? Anyone? If it is 20% more than MT means convert this particular
1.2 MT.
Exactly. So it is 1.2 of MT. Careful about this. So this comes while you are calculating the torque. Okay, you have to consider the value of MT. That is the only change in the problem, guys. Everything is same. Okay. So again, so what has been asked in the problem is to specify the details of a spur gear, he says. If he says specify the details of the spur gear, what you have to do, this is a design-based problem. So we have to neatly calculate the value of M and check for it. Calculate the value of FD and check with the value of FEL, and even check the value of FW for the wear. So all this has to be done. All same procedure again. Okay. 1.2 MT. Exactly. Shall we start the problem? Shall we start the solution? Okay. Okay. So, what is our first step? What is our first step? is to identify the weaker part. Identifying the weaker part. Okay. Guys, before I just start this, I wish all of you to enter your attendance in the attendance sheet. And I will just call some few of the names, and those names are my counseling batch students, and they have to stay in the class once the class has been completed. Okay, we need to discuss something. So I would just give the names in the chat box. Okay. So all these people have to stay. Anurag, Arjun, Ashwin, Dikshit, Danush, Fabaz, Gagan, Ruben, Ravin, Ritvik, Ruhail, one more Ritvik, S. Mohit and Sagar. So all of you, please stay even after the class, after 10 o'clock. Okay. We need to discuss something very important. Okay. And meanwhile, just fill up your attendance. Those who did not copy the question, they can even copy that. Okay. And try to identify the weaker part, everyone. Let us see. Nice. Okay, shall we continue with the problem? Have you identified the weaker part? Yes. Which one is the weaker part? Guys, I'm audible. Okay. Am I audible, guys?
Yes, sir.
Yes, sir.
Okay. Have you identified the weaker part? Which one is the weaker part then? Arvin, what is the weaker part? Whether it is gear or pinion? Sigma D. Okay. Raven Sonal.
Yes, sir.
Have you identified the weaker part?
Still doing.
Okay, what you are doing, just explain us.
Strength factor, sir.
Ah, just show us your notes. Can you just switch on your camera, please? Ah, very good, Praveen. Praveen, you will be solving everything, but the thing is, why don't you interact during the class? Why don't you give your answers? So design is such a subject. When you interact more, you will learn more. It is all concepts oriented. It's all decision making. Whether to take that value, where to take that value, how to take it value, whether the taken value is correct or not, how to check it. So it is all about that. So this all does not come via textbook, does not come via reading notes, does not come via solving it simply. It is all about discussion, it's all about interaction. Then only you'll get to know the concepts. I'm not only telling for Revel, but I'm telling it for all. Please understand how the subject is. The subject is, it's more of concept oriented. You need to make certain decisions in your problems. Based on that decisions only you will arrive at the right answer. The procedure remains same for every problem. There is no absolutely no change in the problem. But at a point, at the middle in the problem, you will be struck. You struck in the sense you will be in a position whether to take it or not, whether to go with the higher value or whether to go with the lower value. You will be in a dilemma, and selecting one would give you the exact result. Selecting the other would give you the exactly opposite result. So that is how the subject is. So I wish everyone to solve the problem. I wish everyone to interact and learn the concepts. So it is only possible when you interact. Okay, for everyone I am saying this. Okay. In this particular problem, now I have to identify the weaker part. So what is the problem I am facing now? To identify the weaker part. How will you identify the weaker part? So it is based on the strength factor. Okay. And the strength factor is given as what? Sigma D cross Y. Correct? So whether the sigma D is given in the problem, whether the sigma D is given in the problem, then what to do? You cannot even start your problem. You cannot even identify what to be done. Which one is a weaker part? You cannot do it. So then how will you proceed with this? Any suggestions? Just refer the data handbook. If you just get any clue regarding this, give me. What has to be done now?
Table 12.7.
Yes? Look for the suitable table where you can select a suitable, what you can say, a design stress value or a material. 12.7, page number 234. Someone has suggested Nitesh. Very good. We'll just come back to that particular table. Okay, we have here. Okay. So in this, is there any criteria so that I can select a material for my gear and get my sigma D value? Is there any criteria that he has suggested in the problem? Look the problem statement once again. Is there any criteria through which I can select a suitable value of design stress based on the material which I have selected? So I have to pick one now. My task is, understand, my task is I have to pick one of these materials. Okay, I have to pick one of these materials. So which material should I choose? So in order to support my decision, is there any statement given in the problem? That is my question. Any statement given in the problem? Yes. Any supporting statements given in the problem is my question. Yes or no? Suhas? Suhas, yes. Hasir kar takshna escape. Suhas. Sushant Naik. Suprita, yes.
Yes, sir.
ಸೊ ಏನಾದ್ರೂ ಕೊಟ್ಟಿದಾರ ಸುಪ್ರೀತಾ ಇದರಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನಾನು ಮಟೀರಿಯಲ್ ಚೂಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುವಂತದ್ದು?
ಇಲ್ಲ ಸರ್.
ಎಂತದು ಕೊಟ್ಟಿಲ್ಲ. ಸೊ when he has given a thing, it's absolutely your choice to pick up a material. Keep this in mind. When he has not specified anything which is related to this, it is absolutely your discretion to select a material. It's wholly depend upon you. You can take any of the material. Hag helidare anta anbuttu, if you take a plastic for your gear material, you'll be awarded 0 for that. Okay, you have to think before you do something. Don't go unnecessary with something like manganese bronze, phosphorus gear bronze. All these materials are used in a worm gear. While we are coming to a worm gear, you'll get to know all these bronze materials are used there. For a understand this, for a spur gear material, always you have to go for a steel, most probably untreated. So we will all go with a single material. I would select and prefer C45 steel, which is untreated, which is most popular, okay, which is readily available, and it is most popular and cheaper, and it has a good hardness also. Never select a material which is having a hardness number less than 200. Okay, so since it is having a hardness of 200, it would be easy for us. So all of you pick this particular material, which is steel C45 untreated, which has a value of 233.4 meganewton per meter square, and 200 is the VHM. So it's the time for the statements. So I would write in another color. Since the material is not specified, just write all these statements in your notes. Since material is not specified, what do you have to do? Let us assume that both pinion and gear are made up of same materials, that is steel C45 untreated. Okay, so give the reference. What is the table number? 12.7 page. What is the page number? Hey, page number is ಕೊಟ್ಟಿಲ್ವಾ ಪೇಜ್ ನಂಬರ್? ಲಾಸ್ಟ್ ಪೇಜ್ 233 234. Table number 12.7/234. We obtain, we have, or we obtain, we have. So sigma D1 is equal to sigma D2 is equal to. We are selecting the same material for both the things. Okay. 233. Just to avoid confusion, just to make our problem simpler. That's it. 0.4 megapascal. So just highlight it in a box like this. Next, BHN of 1 is equal to BHN of 2, which is equal to 200. This would be required while selecting the value of K in the wear load calculation, isn't it? Now, I guess everything else in the problem remains same, except take care of this particular thing where the maximum torque is 1.2 times the mean torque. You have to take care of this while you are calculating the torque for the module calculation. Now decide upon the wake up, everyone. Go ahead with the calculations. If you are facing any problem, let me know. So strength factor is calculated as how? Sigma D into Y. Okay. So you can directly write a sentence, guys. Don't need to calculate also. It is a known thing. So what you can write is, while identifying the weaker part, since both pinion and gear are made up of same material. Is my handwriting legible? Give a frank opinion.
Yes, sir.
Yes,
Are
sir.
you able to read it? Okay. Material, both pinion and gear of made material. Okay. So we can come to a conclusion that, so which one would be weaker, pinion or gear? If both the things are of the same material. We already discussed this. I can come to, therefore, pinion is a weaker part. Pinion is the weaker part. Why? When you are going to come to this conclusion? When both the materials of pinion and gear are of the same material, you can directly come to this particular conclusion. So hence you can write, hence the design is based on the pinion. So said that, continue with the problem. So once we have decided the weaker part, what is our next step? Is to find module. To find the value of module. Okay. To find the value of module. So in order to find that, you have an expression. You already know that. You are very much familiar. It is cube root of 2 times of mt. So just for understanding, take it as mt max divided by sigma d cv k y and z. Okay. So just calculate mt max now. Okay. For that, you have to calculate mt first. It is 2 pi n mt divided by 60. So that is 20 kilowatt in the sense 10 to the power of 3 2 pi cross 1200, which is the speed of the pinion, and mt divided by 60. So your value of mt is 159.15 cross 10 to the power of 3 Newton. And just check the value whether it is right. So now calculate mt max. Mt max is equals to 1.2 times of mt. So it is 1.2 times of 159.15 cross 10 to the power of 3. So your value of mt max would be 191 into 10 to the power of 3 Newton mm. Okay, so this is the value of your mt max. Okay, next, the form factor. Capital Y, the form factor you have to calculate. So you know that it is pi into small y. So pi into, just pick the expression for 20-degree involute system. 20-degree involute system, you have 0.154 minus 0.912 divided by 16. Is this at one value? I have written it directly. So it is 0.3047. Okay. So again, the CV value and the K value is not being given. So what you have to do is, assuming K is equals to B by M, that is equals to 10, and CV value is 0.5. Now, since everything is known, just substitute there. So module cube is equals to 2 cross 191 into 10 to the power of 3 divided by 233.4 cross 0.5 cross 10 cross 0.3047 cross 16. So when you do this, the module whatever you obtain is 4.06 mm. Now, therefore, what you have to do, standardizing above value. So M you can take from the table again, the module table. What is the standard module, guys? Just check and give me the value. Okay, so I can go with 5. Okay. So M is equals to 5 mm. Please mention the table's number for everything. Otherwise, after that, you would be in a confused mode. Okay, where has that particular thing has been taken? Around 29. Okay. Next, once the module is being calculated, what is our next step? What is our next step? What is our next step? Okay, so we shall do one thing. We will stop here and continue the problem from here in the next class. Okay. So the next step is we have found out the module. Even we have standardized it also, but we need to check. We need to check for the design stress. We need to check for design stress so that whatever module we have decided upon is correct. Okay, we will do it in the next class. Okay, and I told you those guys list which I have just pasted there. All of you just remain here, and others can leave the meeting. Okay.